So, once again, good evening to everyone. I hope everyone is doing well today and surviving with the assignments coming in strong. Hopefully, though, the weekend's almost here, so you can pull through until the long weekend and have yourselves a fabulous break. So, we're looking at assignment two today, and I'm just going to, you'll see up on the screen the assignment paper, question paper projected. And if you don't have a copy of it already, you can download one. Remember, if you recall from the previous sessions, there is a download icon that looks like this on the top right-hand corner next to the bin icon. So you can download the assignment question paper here, but I'm assuming that most of you already have this paper and have attempted it as well. So I will be taking you through the questions of the assignment, just the same as we did with assignment one, guiding you along the way, giving you an idea of what needs to be done, where your marks are allocated per question. If you have any questions along the way, please do let me know as well. You can pop your messages into the chat, or if you want to speak up, then you can just press your raise a hand icon at the bottom of the screen. So the same housekeeping rules would apply with this assignment as with assignment one. So as best as you can, please do try and upload your documents as PDF documents. Even if you are taking pictures of them, try to stick to it being uploaded as a PDF, just so that there's no issues when you're uploading it, and then obviously when it comes through on our side. Because a lot of the time with different formats, it doesn't pull through on our end, so some of the information goes missing, or when it's saving a document, there's parts of it that don't get saved altogether. So just maybe as a precautionary, ensure that it is a PDF document, even if you're typing it up on Word. I mentioned also in the previous session that if you're using an Apple device, it often doesn't pull through when you are uploading it as a Word document, because there might not be the same format, or you might not actually be using Word, or maybe some other form of, or some other application that you're using. So just to be safe, try and ensure you upload them as PDF documents, so as to avoid any issues. And then here, there aren't any theory questions, so you don't have to worry about the referencing part of it. But naturally, your safe assign submissions, your percentages will be quite high, most likely, because of the similar answers. But there are no theory questions here. So this assignment was covering 3 learning units. So that's learning unit 3, 4, and 5 that were being tested here. And then you did have choices as well. So it was quite beneficial to you, where for one of the questions, you didn't have to answer both of the questions under that particular category. You could choose. So here at the bottom, if you have a look at under your instructions, section A comprises of 2 questions, both need to be answered. And those were based on your learning unit 3 and 4 content. Sorry, not learning unit 3 and 4, learning unit 4 and 5. So these were section A. And then learning unit 3, which was section B here, had 2 questions, but you would only answer one of them. So please do pay careful attention to that, because previously we've had students attempt both of them as they didn't read the instructions correctly. So I do advise that you read through the questions, look at what you're comfortable with in terms of the learning unit 3 content. If you feel like, and remember, this learning unit is based on your grouped and your ungrouped data. So if you feel like you're more comfortable with grouped, then you're only answering the question based on your group data. If you are more comfortable with your ungrouped data, then you will answer the questions only based on those. So you're going to choose between the two of them, not both of them. And you'll see that in the mark allocation as well, because your paper does sum up to 100. So if you're answering all of it, then it would be 140. So please pay attention to that. So section A, completely compulsory, based on learning unit 4, which is your linear regression and correlation analysis, learning unit 5, which is your basic probabilities, and then you have your grouped data and ungrouped data, which is learning unit 3. This is section B, and then you'll just choose one of them. Sorry, let me just have a look at the... Okay, perfect. Kath, you're looking at the questions. Okay, so I am going to go ahead and get started, and you can, as I said, just pop your questions into the chat as we go along. So section A here is, like we said, based on learning unit 4 and 5. There are 2 questions. You will answer both of these. So question 1 is based on your linear regression and correlation analysis. And this is learning unit 4. So I'm just going to write that at the top here in line with it. It's a 30-mark question. They've said to you that the table below indicates the number of years of experience of a sample of salespeople who work for Hornbill Pty and their corresponding sales in thousands of rands over the last 2 weeks. So they've given you the years of experience in your first column. This is your X value, then your sales in the second column, your Y values. And the first question said to you, and also remember your X and Y values are explaining to you which are your dependent and your independent variables. So X is always your independent variable, Y is always your dependent variable. So essentially what they're saying to you here is that the sales levels in thousands of rands depends on the number of years of experience of the salesperson. So question 1.1 said to you to complete the table below and then apply the relevant formula determining the line of best fit for this bivariate data set, and don't change the units for the variables. No marks will be awarded if the table is not completed. So this is for 15 marks, which naturally then indicated that you would need to complete the table. They said to you here that this is the table you will need to reconstruct in your answer booklet, and you're putting in the columns X, Y, X squared, and X, Y. So here you will complete the table. Remember, the first 2 columns are already given to you, so you're literally just copying that copying that information, copy and paste to the relevant columns here. And then you have X squared, which is literally just squaring each of the X values from, again, the information at the top, literally just squaring each of them. And then XY, literal to the words XY. Remember, when there's no sign between your variables, it's a given that it's multiplication. So it's each X value multiplied by the respective Y value. So literally just multiplying them. So once you're done with that, and I would suggest that for the purpose of the question, you'll copy the table or follow the format of the table and fill in exactly as it looks. But just for your own purposes, if you're writing this down roughly somewhere as you're working with it, include the column for Y squared, because just to reiterate, when you get to this calculation and ensure that your answer is correct, you need the Y squared value. So just to make sure that your answers are correct on the way as you go along, you can include the Y squared value to just ensure that your figure for the coefficient of correlation is correct. So back to what I was saying in terms of the table, once you're done filling in the values, don't forget about the total column at the bottom, sorry, the total row at the bottom. So you're summing up. Remember, the symbol for the sum of is this. So it will be the sum of x for the first column, the sum of all of your y values. So literally just adding up all the y values in that column, then adding up all the x squared values to give you the sum of x squared, and then adding up all the xy values to give you the sum of xy. Once you have that, you're then not done. You will need to calculate the values that determine your line of best fit. So once you're done with the table, you'll then need to substitute values into your formulas for the line of best fit. The formula for your line of best fit is y is equal to a plus bx. So in this formula, you are calculating the values of a and b. Here, you will start off with calculating the value of b first. And the formula for this, which you'll see in your slides in your textbook, is n multiplied by the sum of xy minus the sum of x multiplied by the sum of y. And then in your denominator, n times the sum of x squared minus the sum of x within brackets, then squared. So having the table drawn up for you makes it quite easy for you to substitute, because almost everything here where it has a symbol, actually everything that has a symbol, the sum of, has already been calculated in the table. So for instance, your sum of x needed here and also here is taken from the first column. Your sum of y is needed, and I'll do that in a different color. So your sum of y is needed here, and then your sum of x squared is needed here, and then your sum of xy is here. So everything that you would have needed, here is your yellow as well from the first one. So everything that would have been done in the table is then put into the formula. N is looking at your sample size, so how many values were given to you in total. So remember they said to you that this was sorry guys, I think I got cut off there for a second.
Akila, there's a question from Abraham. Would you include the line of regression in 1.1?
Yes, you will, because I'm assuming you mean the calculation of it. So it is part of question 1 because they did ask you to determine the line of best fit. So they said by completing the table, you then would determine the line of best fit. So they said by completing the table, you then would determine the line of best fit. So once you've done the table, completed the figures, filled in the values into the table, calculated the sums at the bottom of it, you're using that information then to calculate the values that go into your line of best fit and then putting together that line of best fit as well. And remember with that, just also building on that. Sorry, Kath, you wanted to say something?
No, I'm just saying Abraham said thank you. Good.
Okay, perfect. Over and above just the information that they provided you with in the question, if you look at the mark allocation as well, it is pretty high. So it wouldn't just be 15 marks for completing that table. You naturally then would have to very carefully, obviously, look at the information or the question itself and what they asked you for, but also looking at the mark allocation will give you an idea of whether you are just doing the table and leaving it as that, or whether there is more to it. And most of the time, it goes part and parcel. It's hand in hand where you're filling in the values in the table, and that leads you to your calculation of A and B. So that's your formula for B. And then only once you're done with the calculation of B will you calculate A. And remember, this is because the value of B is needed for the formula for A, which would read the sum of Y minus B multiplied by the sum of X, and then that's over N. So again, here the sum of Y is just taken from the information in your table. It's already done for you. Your B value is from the answer at the top, and then the sum of X also already done for you in the table, and then N again is your sample size. So that would then lead you to the values of A and B, and you're going to then take them, plug them into the formula A y is equal to a plus bx. Remember, it is possible, not that it is specific to this example, just in general, it is possible that both a and b can be negative numbers as well. So please don't be alarmed if you do end up with a negative value, whether it's in this question or any other question based on this type of content. It can be possible, it can be such that a and b are negative numbers as well. So that's question 1.1. And then question 1.3 asked you to use your calculator and determine the coefficient of correlation for the data set and interpret your answer. So here they did specifically ask you to use your calculators. Another common error that students make is that instead of using the calculator, they write out the entire formula for the coefficient of correlation and calculate that. Although it is the correct answer, it was not the correct method that was used. So you will not get the full marks for that. You will get the mark for the final answer, but naturally your whole method of getting to it isn't correct. I mean, maybe you can get away with it for now, but preferably we do advise you stick to what was actually asked in the question. So here, specifically because they asked you to use your calculators, you're going to just put in your final answer. So here, remember the steps involved when you're using
Hi,
your
Keela.
calculator.
It's
Sorry,
Cass.
yes.
Sorry, just because there's a couple of questions.
No problem.
Vijeshna says, do you mean you mustn't show the formulae? Ricardo's asking, do we need to show the steps of the calculator or just do the calculations?
So it would just be the final answer from the calculator. You don't need to show the entire method of that. You don't need to write out the steps either that you followed in terms of getting to that answer. It's literally just the final answer. But when you are writing the final answer out, you can remember this is the letter R that you're calculating, your coefficient of correlation. So you can write it out as a decimal first. Let's just hypothetically say it's 45%. So you'll show your decimal of 45 and then your percentage of 45%. If it is a 2 decimal place as a percentage, then you can leave it as 4 decimal places here. So let's just say 45.13%. So when you write that out, you'll show the decimal first. That would be a mark to that or a couple of marks to that. And then as a percentage, you'll show 2 decimal place percentage and then your interpretation as well. So that's how your marks are allocated for that question. So when you are doing it on your calculator, just to reiterate very quickly, you would choose or you'd press the mode button on your calculator and then choose the option that says stats. Then the option that says A plus BX. And I'm going to quickly write that on the screen as well. So you'll press the stats or mode button on the calculator, choose option 2. I think it's option 2, which says stats mode. And then you'll choose the option that says A plus BX. I'm not going to say which number that is because some calculators are different to others. I think the newer versions have it as a different option. I'm not sure if it is still option 2. And then once you're done with that, you're going to type in each X value. So you'll input your X values into your calculator. So basically you'll start with the number 11 and you'll press enter and then the next number enter. So I'm just going to say enter after each value. No, you won't be marked down for it, naturally not, but obviously you don't want to spend unnecessary time on that. But if you feel like you're comfortable writing it down and then following the steps as you go along, that's perfectly fine as well. And then you'll navigate to the next column so that you can start entering your Y values. So to navigate to the next column, you're literally just using your right arrow and it will take you to the column on the right that's labeled Y. And then you'll input all of your Y values, also just pressing enter after each value is put in so that it can take you to the next line. And then once you're done with that, you're going to press AC on your calculator. So I'm just going to write it at the bottom here. Once you're done with AC, this saves your data onto the calculator. And then you're going to press Shift and the number 1. Then you'll choose option 5, which is the regression option. Sorry, I'm going to write it at the bottom here, just where I have some space. So this would say REG. And then you're going to, so it depends on what you're looking for here. So if you are looking to just check that your answer for A was correct when you calculated it in question 1. Oh, sorry, circled the wrong thing. So in question 1, remember, you got the values of A and B for the formula Y is equal to A plus BX. Just to check that A is correct, you can choose option 1 and press the equal to sign. This is just for your own benefit, not answering question 1.2 here. We'll get to that in a second. So option 1 and press the equal to button. That will tell you what the value of A is. So you can calculate the value of A using the formula and then use your calculator to check that it is correct. Then you can also check that your B value calculation was correct. You'll press option 2 and equal to if you wanted to check B. And if you are, and this is for question 1.3 here. Actually, I think I skipped 1.2. Okay, I'm coming back to question 1.2 just now. So for this one, which is to calculate the coefficient of correlation, which is R, it is option 3 on your calculator. It will literally say R. It will also say A and B for option 1 and 2. So option 3 here and the equal to sign will tell you the value of R which you need for question 1.3 here. And here and the equal to sign will tell you the value of R which you need for question 1.3 here. And in between, if you want to check all, if you're checking all 3 of them, so let's suppose you did all of the steps up until point 8 here, and then you first start off by wanting to check that your A value is correct, you'll press option 1, the equal to sign, it will give you the value of A, and then you start with 7 again, with step 7 again. So you'll press shift and the number 1 again, and then you'll choose the regression option again, and then now you want to check that your B value is correct, so you'll choose option 2. So you'll press the number 2 equal to, it will give you the B value, and then again if you want to check that R is correct, again you'll start at step 7 again, you'll press shift, the number 1, the option that says regression, and then option 3 to check that your R value is correct, or just to work out your R value. All right, so this is your coefficient of correlation. And remember, this is telling you the strength of the relationship between two variables. So you are looking at, is there a positive or negative relationship between two variables, or is there a is there a weak or a strong relationship? So when you are interpreting this, you need to say both of those. So either positive or negative in your interpretation. Obviously, you'll need to put it into a proper sentence. And then you also need to say whether it's weak or strong. So both of these need to be included, but it will be either one in each of them. So it's either weak and positive, or strong and positive, or it's weak and negative, or strong and negative. Okay, so that's question 1.3. Let's have a look at question 1.2 here. So question 1.2 is saying to you, sorry, just backtracking a bit. I didn't even realize I was below the table. So here it says, estimate the sales in thousands of rands that were produced in the last 2 weeks by a salesperson who has 7 years worth of experience. So this is actually a continuation or building up on using what you had in question 1 calculated in question 2. So remember, in question 1, we would have calculated the values of A and B that go into the regression equation, which reads y is equal to A plus bx. Once you have the values for A and B, your last step in question 1.1 would have been to plug in the values into that formula. Once you have the formula for question 1.2 now, your years of experience is your X variable. So in place of your X variable in this formula, once it's now put together from question 1, you'll substitute 7, and so you'll have values for the right-hand side, and you're using it to calculate what the sales would be, what the Y value is on the left-hand side. So all you're doing is substituting for the value of X in the formula, and this will tell you what your sales would be for a salesperson who has 7 years worth of experience. And then the last question here, 1.4, asks you to compute the coefficient of determination for your data set and also interpret your answer. So the coefficient of determination is quite straightforward. It is R squared. So it's just taking your answer from the previous one and squaring it. It is expressed as a percentage because of your interpretation. So once you calculate R, you're literally just going to take the R value, square it, multiply it by 100, and it will give you your answer as a percentage. Please stick to 2 decimal places unless it's specified otherwise for a particular question. And then once you're done with that, you will interpret your answer. So remember, your coefficient of determination tells you the extent to which a change in X will bring about a change in Y. So it's basically the percentage variation in the X variable in your Y variable that's explained by variation in your X variable. So we know that when X changes, Y changes as well. But we want to know that, so a change in X affects a change in Y. We want to know to what extent does that happen. So here with your coefficient of determination, it's telling you the extent to which a change in X brings about a change in Y. So that's question 1. Any questions here that I haven't answered or that Kath hasn't answered?
It looks like they're all over it, Akila. They're Ricardo just wants to know if he needs to draw a graph for 1.1.
No, no graphs anywhere.
Okay. So on your different calculators, also when we select option 2 of stats and enter all the X values and then press enter, but my calculator is not going to the Y.
So
I've
on
got a
your
document I can share with you, Akila, or have you got one on hand?
I do have one. Let me see if I can share that. But the document just has the same steps as the ones I've written on the screen. So they're not going to be a visual of how the calculations are done, what the calculator looks like. What calculator are you using? Okay, so remember when you are, so I see that you said once you enter your X values, let me just go back to that. So when you are entering all your X values, and naturally you're pressing the enter button after each X value is entered. When you are going to the next column, your Y column, firstly, can you see the Y column on your calculator? Is it appearing? Okay, so you're just using, remember on your Casio calculators, I'm just going to draw like a rough version of it. Somewhere at the top here, you have a round button that has your arrows. So it has the arrows in every direction, and you'll just use the one that's pointing to the right here. Sorry, it's a minuscule drawing, but the one that has the arrow to the right, you're just going to press that and it will take you automatically to the Y column. And then also it might take you to the last value. So once you entered your last X value here in this column, it's automatically going to take you to the last Y value as well. So you'll just press your arrows pointing up to take you all the way to the top. And then once you are at the top, you can start with all of your Y values here. Okay, so I think that should be okay. It will ignore the last value, but automatically your calculators do that anyway. So once you're done with pressing enter, if there's 6 values, then it automatically will just go to the next row. But just try to, if you know that there are 6 values, once you're done putting in the figure for the last one, the 6th value, just automatically press your arrow taking you to the right. So I think we can go ahead to question 2 then, and this is based on Learning Unit 5, which is your basic probabilities. And right at the top, they've said to you that all of your final probability answers in question 2 should be given as percentages to 2 decimal places. So I do, again, reiterate that please stick to what they are asking you for in a particular question. As a general rule, your assignments do, when it comes to stats modules, they do specify that your answers need to be rounded off to 2 decimal places, but specific questions can have specific requirements as well. Some questions might ask you to round off to a whole number. Some might require percentages as 2 decimal places, and so on. So like in this question, they wanted it as a percentage, but also just to 2 decimal places. Sometimes they might ask you, and you'll see in question 2.1.1 here, they want you to leave your answers as fractions and not as percentages. So please do pay careful attention to what they're asking you for. It can change question by question. So question 1 here, 2.1 here, is saying to you that what the question entirely is based on is probability trees. So they've said to you that a bag contains 9 green and 11 blue marbles. You are asked to select 2 marbles from the bag. The first marble selected will not be placed back into the bag. And that's important as well because it's basically saying to you that it's reducing your sample size or the number of marbles that you can select from the second time around. And then they said to you, construct a probability tree to indicate the various possible outcomes and their probabilities as fractions within brackets. So please make sure to adhere to that. And that was for 7 marks. And once you've drawn up that probability tree and calculated the various possible outcomes, you then are asked a question of what is the probability that 2 selected marbles will be the same color. So here, when you're constructing your probability tree, and I'm just going to do a quick example of this, just for the benefit of everyone as a whole, but I'm just going to change the figures here because I obviously cannot give you the answer to that. But I'm just going to change the figures here and make that 6 and 8. So here, if you're drawing this up and it said to you that the bag contains 6 green and 11 blue marbles, you're firstly looking at the fact that 2 marbles will be selected. And what happens the first time around does not affect what happens the second time around. That's because probability trees are independent in nature. So you're going to look at what happens the first time around and then thereafter look at what happens the second time around. So when we're looking at filling in the figures here, we only worry about, actually, let me do that again so that I can only focus on the first one and then the second. So let's look at the first marble being drawn. Your options are green and blue. You have 6 green and 8 blue, which collectively then tells you that you have 14 marbles to select from. So this is, again, just another example to give you an idea of how to go about answering this. So for the green, 6 out of the 14 are green, which would make the first branch of the tree at the top out of the 14 are green, which would make the first branch of the tree at the top 6 over 14. Then the chance of selecting blue the first time around is 8 out of the 14. So 8 over 14 at the bottom for the second branch. Now, they said to you that the first marble selected will not be placed back into the bag. So from 14 marbles that you currently have, you're going to remove the one which was selected the first time around, and that will now leave you with 13. And again, what happened the first time around does not affect what happens the second time around. Meaning, if you selected green the first time, you can still either select green again the second time, or you can select blue the second time. And again, vice versa, if you selected blue the first time around, you can still choose blue the second time, or you could choose green the second time. So now you're going to put in additional branches under both green and blue. And this is indicating to you what I just explained just now, that if green was selected first, you can still select green or blue the second time. And if blue was selected first, you can still also either choose green or blue the second time. Now, because your sample size has declined, this is then saying to you that you only have 13 to choose from the second time. And so your denominator for the fractions becomes 13 the second time around. So here, and now I'm going to ask you to focus on only the first part of the tree. Sorry, let me just erase that so I can write in pen. So only this portion here, meaning nothing at the bottom here, just the part where it says green, first, and then green and blue. So we're looking at just the first portion. And what we're saying here is that if a person chose green the first time, they still can choose green again, but if they chose green the first time, there's one less green available. So instead of there being 6 green to choose from, there's now 5 green to choose from. Sorry, my writing is quite small. Okay, so now that you have the first part of it, you're then going to look at what the probability is of choosing blue. So if you chose green the first time, then all of the blue that initially was there was untouched. So all 8 blue are still available to choose from if you chose green first. Now at the bottom, it's the opposite way around. So here at the bottom, if you choose blue first, there's 8 blue available. And I'm actually going to start with the blue at the bottom here, and then I'll look at the one above it. If you choose blue the first time, there's one less blue available. So there's now 7 blue to choose from. And if you choose blue the first time, that would mean that the green is untouched. It is what it originally was. All 6 are still there. So that would be 6 over 13 here. And like that, you're done with your probability tree. You have looked at all of the possibilities associated with selecting the first marble and the second, and you've left it in its fraction form as well. Now, they did also say to you here that you would need to indicate the various possible outcomes and their probabilities. So now we need to calculate the probabilities associated with each one of them. So now for the probabilities, you're going to look at the fact that with a probability tree, and I said this to you when we started it just now, it always is the independent rule that's applicable. So the independent rule says to you to calculate, and as a general formula, the formula is the probability of a, sorry, let me write this where I have more space. The probability of A and B occurring is calculated as the probability of A multiplied by the probability of B. So this is the general independent rule formula for this specific question as well. It's a general independent rule formula which you'll apply to this question as well. So you're going to, and I'm going to highlight them as I go along so that you can visualize what we mean here. So the first one would be,
Sorry, just
yes,
Catherine
sorry.
interrupting. There's a bit of questions as to would you prefer the answers to be in percentages, fractions, or decimals?
Everything in fractions for this question. For the next one, it will be a percentage to 2 decimals. So because they specifically asked you for the fractions here within brackets, you leave everything, even the probabilities that we're going to calculate now, they will remain as fractions. But for the next question, because they didn't specify within brackets, you'll follow the general rule that they said at the top, where it will be a percentage to 2 decimal places. Okay,
Thanks,
so
Peter.
no problem. Back to the probabilities. I just want to change colors here so you can identify. So back to the probabilities that we're now calculating. It is based on this rule again that we had said would be applicable to probability trees. It is the probability of A and B is calculated as the probability of A multiplied by the probability of B. So now for the first one, you're going to look at the probability of choosing green the first time, because that's the color here at the top, and then green again the second time around. So when we write that out, we will say the probability of green first and then green again. And that is calculated just like we saw here. If it's a probability of A and B, then it's calculated as a probability of A times the probability of B. So the same with this question. If it's a probability of G and G, it's a probability of G times the probability of G again. So it's 6 over 14 multiplied by 5 over 13. And that would give you an answer of 15 over 91. Then the next one, and I'm going to do this in a different shade so you can identify that, is green the first time, but blue the second time. So now it is the probability of green and then blue the second time. So now it is the probability of green and then blue. So that's 6 over 14 for green, and blue is 8 over 13. And that is 24 over 91. And then the next one, and again, I'll do this in a different color so that you can see that it's blue and then green after that. So blue first and then green. So that would be 8 over 14 multiplied by 6 over 13. And that's also 24 over 91. And then again, the last one, let's do that in this color. It's blue and then blue again. So that's 8 over 14 multiplied by 7 over 13. And that is 4 over 13. Okay, so that would be question 1 then. You have drawn up your probability trees together with all of the possible outcomes that can occur, and then you also calculated the probability of each one of them. Question 2 then is saying to you, what is the probability that 2 selected marbles will be the same color? So all you're going to do, and this is why it's so beneficial to write out these bits within brackets here, sorry, these bits next to the tree here. So you're looking for all of the ones that have the same colors. That would be green and green and blue, because those say the same color within brackets. The other two have green and blue and then blue and green. So you're only focused on the ones that have the same colors. And all you're going to do is write that out and add them. So it's the probability of green and green plus the probability of blue and blue. So the probability of green and green is the 15.91. The probability of blue and blue is the 4 over the 13. So 15 over 91 plus 4 over 13. And that would give you 43 over 91, which as a percentage to 2 decimal places is 47.25%. Okay, so that's the first part of question 2. Any other questions that might not have been answered already?
Akila, all seems good. Everybody seems happy. Akila, I think you might be muted, but everybody's happy up until now.
Oh my goodness, I was talking to myself for the last few minutes.
Yes, clearly.
So, okay, so I'm going to repeat. So I was saying that question 2.2 here is based on your contingency tables, your basic probability calculations. These are incorporating all of your general rules in terms of your type of probability. So you have your independent rule, your dependent rule, your mutually exclusive, your non-mutually exclusive, and so on. The list goes on. So here, it's a pretty straightforward question. It's also one where you're able to score your marks in. So they've given to you here a contingency table that has two categories. So you have your male and females, and then you have the preferred brand of cell phone. So there are 450 people in total, and they have said to you, so here I'm just going to give you an idea of the rule that needs to be applied. Because if I give you anything more, I'll be telling you the answers to these. So the first question says to you, what is the probability of randomly selecting a respondent from the sample who prefers Vivo? Please make sure to adhere here to that rule at the top. So 2 decimal places and a percentage. You don't need to interpret anything unless they did ask you to, but they didn't ask you to in these questions. So you're literally just calculating the answers. So when they are referring to here, they said the probability of randomly selecting a respondent who prefers Vivo. This is just looking at one single variable. So they're not saying the person's gender together with what cell phone brand they prefer. They're just saying that they want to know how many people or what's the probability of a person selecting a Vivo. So this is an example of a marginal frequency where you are literal to the words marginal, getting your answer from the margins of the table. So it's either your total column or your total row here that you're using for or looking for your answer in. It is just one single variable that's being looked at. The number of, or sorry, the probability of selecting a person who prefers Vivo. Then the next one says to you, what is the probability of randomly selecting a respondent from the sample who is not female? So immediately when you see the word not, it signals to you that this is the complementary rule. And remember, the complementary rule as a general formula says to you that the probability of an event not occurring is calculated as 1 minus the probability that it will occur. So, for instance, if you're saying that the chance of it raining today is 20%, and we asked you what is the probability that it will not rain? So, what is the probability that it will not rain? Then all you're going to say is, because they said the probability of it not raining, you're going to say the probability that it will not rain is calculated as 1 minus the opposite, the probability that it will rain. And we know that the probability that it will rain is 20%, so it'll be 1 minus the 0.2, and that would give you 0. Probability that it will rain is 20%, so it'll be 1 minus the 0.2, and that would give you 0.8, which as a percentage is 80%. So whenever you have the word not included, you're using the complementary rule. So it's a probability of it not happening being calculated as 1 minus a probability that it does happen or that it will be selected. So that's your complementary rule. Then you have what is the probability of randomly selecting in question 2.2.3. What is the probability of randomly selecting a respondent who is female and prefers Samsung? So this is an example of a joint frequency, meaning it's not one single frequency or one single variable you're looking at any longer. Rather, you're looking at two different variables that have been identified. So here, the two things you're looking for is the person being a female and also that they prefer Samsung. So instead of looking at the total column and the total row, sorry, just want to make that smaller, you're now looking at everything in between. So your answer will lie in the center somewhere here. So from all of the values within that block, it would be real or respective to female and someone who prefers Samsung. So remember, your joint frequencies are looking at two variables at a time, not just one single variable. And you would look at what are each of those two categories, and it's looking at a joint, so both of them occurring together. And then 2.2.4, the last one here, is saying to you, what is the probability of selecting a respondent who is male given that they prefer Apple? So here, the word given indicates to you that this is a conditional probability. So a conditional probability immediately is indicating that your sample size changes, meaning instead of n being your denominator, instead of your entire sample size being your denominator, you are narrowing it down to the given portion. So if I said to you, for instance, what is the probability of selecting someone who prefers Vivo, given that they are female, then to answer this, the first thing you need to pay attention to is what is the given. So it says given that they are female. That immediately means that the denominator of your fraction is the number of females. So from your table, here's the number of females. It is 250 females. So that becomes your denominator, meaning you're no longer looking at all 450 people. You're looking at only the ones that are female because you now know in advance that it is a female. So 250 becomes your denominator. It's narrowed down your sample size. And your numerator then is going to be both the variables. So a person who prefers Vivo and is female. So in your table, you're going to go to in line with Vivo and female, and that's going to be in line with that and that. It's the 40. So it would be 40 out of the 250. And you'll go on to calculate your answer as a percentage. Okay, so that is the first part of question 2.2. It was your basic probability questions based on your contingency table. Then on the next page, you'll see at the top, it's also the first one is the same one that I just explained now. So it's also a conditional probability. Let's read it and you'll see that it is a conditional probability as well. So it says to you that the probability that a randomly selected employee of company Y is female is 0.6. The probability that an employee of the same company works in the marketing department, given that the employee is female, is 0.2. What is the probability that a randomly selected employee of the company will be female and will work in the marketing department? So here again, the moment you see the word given, it immediately says to you that it is a conditional probability. So it's the same idea as we had seen here in this example at the top, where remember when I was plugging in the values here, I said to you that the figure at the top would have to be both FIVO and female, meaning it was the probability of, and I'm just going to write the letters here, VIVO and female. The one at the bottom was just the given portion. So it was given that a person was female. So this was a probability that it was a female. Now, this formula that I wrote here is the conditional probability formula. But using the general letters A and B, I'm going to write out the formula here. It's the probability of A given that B has already occurred is calculated as the probability of A and B occurring or being selected over the probability of just the given one. Now, in this question, they told you that the probability of an employee being a female is 0.6, and the probability that an employee of the same company works in the marketing department, given that the employee is female, is 0.2. So basically, what you have is this figure at the bottom and this figure on the left. And you are asked now to calculate the figure at the top, meaning you know what the probability is of the person being a female, you know what the probability is of the person working in the marketing department is given that they're female. And now you want to know what the probability is of it being a female and someone who works in the marketing department. So you're literally just substituting into the formula to work out your unknown figure, but it's obviously based on the information you've provided. So you need to identify what do we have versus what do we need to calculate, and then substitute into the formula and work backwards to your answer. And then the last one here is saying to you that there are 13 teams participating in a general knowledge competition. What is the probability of correctly predicting the top 4 teams at the end of the competition in the correct order? So naturally here, it is a counting rule. You need to identify which of the counting rules are looking at when they are placed in the correct order. Once you have identified that, it's either a combination rule or a permutation rule. Once you've identified which of them it is, at the end, they asked you what is the probability. So whatever answer you get here, please remember to convert it to a probability by saying 1 over that answer. And make sure again to stick to the probability by saying 1 over that answer. And make sure again to stick to the percentage as 2 decimal places answer. Okay, so that's question 2. Any questions here that haven't already been answered?
No, Akila, everybody's been very quiet. So obviously your explanations are perfect.
Okay, so do you want to, Nate, do you have any questions? I see that you're saying it is a bit confusing.
Yeah, okay, so everybody's slightly stunned, but Nate and Ricardo and those in my session, tomorrow night we're going to go over this again. So if you need further clarification, we can unpack it.
I'm sure it will be like that across the board though, because I think that everyone is only getting to learning Unit 5, or with my class, it was just looked at very recently. So I just uploaded videos for them. I think it was last week. So I think everyone will still be a bit wary when it comes to that one. It was the very last learning unit of the content for the assignment, and it also would have been the one that was either very recently touched on, or is still about to be touched on. So I think it will be across the board that question 2 here, learning unit 5 content, is just something they'll need to spend a bit more time on and have a look at in a little bit more detail, because I'm thinking based on how many sessions we've had so far, I think most of us have only really been able to get through content for learning unit 4 properly. And then, as I said, with my class, I just sent them the content last week sometime. So I don't think everyone's really got to much of it yet.
Yeah, Akila, I completely agree. So we can unpack it a bit further with them. And probability can be pretty confusing.
A bit much. Yes,
Yeah,
definitely.
okay.
And
But
yes,
thank
as I
you.
said, it's also the last of the learning units to be tested. And it's, I think that the due dates were a bit tight for the content because it was within the same month that assignment 1 and 2 were due. So it also just created a bit of a, you know, a difficulty there with covering enough content for both the assignments.
Yeah, absolutely. But thank you. Your explanations, personally, I think have been amazing, and we'll certainly unpack it with our groups further.
Yes, definitely. Okay, so I think we can move on to question 3. Yes, I did have a look at that schedule, Gaston. I agree. It has been crazy. And 2 assignments for the same module in a month is obviously quite a bit as well. So I can imagine it must be quite crazy on your end. Okay, so question 3 and question 4, both from Learning Unit 3. They are your grouped and your ungrouped data. So I'm going to write down here at the top of this section B. This is entirely Learning Unit 3. So the first question, question 3 is your ungrouped data. And then question 4 on the next page is your grouped data. And then obviously, as you can see, they're both for 40 marks, which also just indicated to you that you're not doing both of them. It would be one or the other. And that would naturally be whichever you feel more comfortable with. So here I'm going to look at both of them, both questions. And we're going to look at, in general, what's expected from you for each question and how to go about the calculations for them. Just a general idea without giving you the answers to them, of course. So the first question here says that the following data set indicates the number of radiators sold per week by a local company that sells car spares over a random sample of 11 weeks. So they've also indicated to you just from that your sample size, which is denoted by the letter N, is 11. So here they've listed out the values for you in ascending order, which is also quite useful because you then don't have to worry about doing that when you get to some of the questions which require your answers, your values to be in ascending order. So it's already in ascending order from smallest to largest. You know your sample size. And then they said to you to calculate the following. Though they didn't mention here whether to round them off and so on, you can just follow the normal rule of your 2 decimal places. So wherever they don't specify, you'll just go with the general rule that they state on your cover page of your assignment to go with 2 decimal places. So question 3.1 here says to calculate the mean and naturally interpret your answer. So your mean when it comes to your ungrouped data, and remember ungrouped data is where your values are simply listed out for you. There's no categories, there's no groups of data. It's just individual numbers that are listed out for you. It's literal to the word ungrouped. It's not grouped, it's not categorized, there's no lists. It's random figures. So for the mean, it is calculated as a sum of your values divided by the number of values that there are. So it's literally just summing up all of your values, dividing it by n. When you're interpreting, remember your mean is your average. So here you were looking at the number of radiators sold per week. So it'll basically be the average number of radiators sold per week, dot, dot, dot. That's the first one. The second one is asking you to identify the mode. This is by far the easiest question when it comes to your ungrouped data. And the mode is under ungrouped data as simple as identifying the number that has occurred the most frequently. So you'll find the most common or most frequently repeated value. That would be your mode. And then to interpret your answer, literally what the mode is, your most frequently occurring number, is how you'd interpret it. So you'll say the most common or the most frequent number of radiators sold per week, dot, dot, dot. So that was for 3 marks. Then the next one is your median. So your median has a little bit of work to it. The first step generally is to rearrange your values. So I'm going to write it at the side here. With your median, you would first rearrange your values. But in this case, they're already rearranged for you. They're already in ascending order. So you don't have to do that. The second thing is to determine the position of your median. Under your ungrouped data, the position is n plus 1 over 2. This is going to tell you where to locate your median or which value it will be. And then the third step is to actually locate your median or to determine your median. So here you would identify which value is your median and just simply write out that this is your median. Interpreting it again, remember the median is your middlemost number. So it separates 50% of your data, the first 50%, from the second 50% of your data. So when you're interpreting it, you can literally say that it is the middlemost number, that it separates 50% of your data, or that 50% of your data lies below this, 50% lies above it, that kind of thing. Then the next one is your third quartile. So your third quartile follows the same steps as your median does. The only difference is in step 2 here, to determine the position, it's determined in a different way. So step 1 is to rearrange our values, but again, that was done for you already here. Step 2 is to determine the position. And under ungrouped data, the position of your median is calculated by 3 multiplied by n plus 1 over 4. Please pay attention to the brackets here. Remember, it is not 3n plus 1 because then you're attaching the n to the 3 or the 3 to the n, which is not correct because you will end up with a different answer. Make use of the brackets. So it will be 3 multiplied by n plus 1, and that would be divided by 4. Again, if you are multiplying the 3 by the n, you're going to end up with the incorrect answer. So please make sure the n plus 1 is within brackets and then the 3 is on the outside. So that will give you the position of your quartile, and then you will again determine the value in step 3. Interpreting it, remember your quartiles. So I'm just doing a rough illustration here. Separate your data set into 4 equal parts. So the first 25 to the next 50, 75, and then 100%. So your midpoint, which is quartile 2, or your median, is separating the lower 50% from the upper 50%. And then going to erase that. Your 25% Q1 is separating the lower 25% from the upper 75%. And then the last one, which is your Q3, here at 75%, is separating the lower 75% from the upper 25%. So when you're interpreting here, you can then interpret in the same way. You can say that 75% of your data lies below this point, or the remaining 25% lies above this point, ... Okay, then question 3.1.5 is asking you to calculate the 60th percentile. So your 60th percentile is also following the same steps as with your median, as with your quartile. It is to rearrange. Once it is in order, then you're going to calculate the position, which is calculated as p multiplied by n plus 1 for your ungrouped data. Once you have that, you're then going to determine your value. Now here, when you get to your position, you're going to have to do a little bit of a calculation first before you get to your percentile. And then when you're interpreting it in the same way that I had shown you just now on your number line, you are looking at the 60th percentile. So I'm going to say here, 60th percentile. Actually, that's too far, but we'll just assume that's the 60th. And it is telling you that 60% of your data lies below this value, and then the remaining 40%. It is telling you that 60% of your data lies below this value, and then the remaining 40% will lie above this value. So when you're interpreting it, you'll use that in your interpretation of your 60th percentile. But again, remember, it needs to be in line with the fact that you're looking at the number of radiators sold per week. Then the next one here is your standard deviation. So they said to you to use the relevant formula. So use the relevant formula, and no marks will be awarded if the answer is simply obtained directly from your calculator. So you can see that from the mark allocation as well, you would need to do a bit more than just get an answer from your calculator. The formula for your standard deviation under your ungrouped data is the sum of x squared minus n multiplied by your mean squared over n minus 1. So here, remember the root firstly. Please don't forget about the fact that it's the square root of. Then the portion that says the sum of x squared is literally just squaring each of your values that were given to you. So squaring 25, squaring 30, squaring 32, and adding them up. So basically, 25 squared plus 30 squared plus 32 squared, and so on till you're done with all of your values. That will give you the sum of x squared at the end. And then n, you already have, they gave it to you in the information. The mean, which is denoted by the symbol x bar, this was already calculated in question 1. And then in your denominator, it's n minus 1. So again, n you already know, and then minus 1. So most of the information here was already done or given to you. The only thing that you actually needed to calculate for this question was the sum of x squared. They didn't ask you to interpret this one, so you didn't need to worry about it. And the next question said to determine what the coefficient of variation for your data set is. So your coefficient of variation is also based on values that were previously calculated. It's your standard deviation, which you calculated in the question above this, before this, and it's over your mean, which you calculated in question 1. So it's your standard deviation over your mean multiplied by 100, and that would be your coefficient of variation. It is a percentage, which is why it's multiplied by 100. So please make sure to leave that as a 2 decimal percentage. Then question 3.1.8 here asked you to determine the value of the coefficient of skewness using the approximation formula and interpret your answer. So the coefficient of skewness is calculated using the formula of 3 multiplied by the mean minus the median over the standard deviation. So the mean you already calculated in question 1. The median you also already calculated in question 3. The standard deviation you also already calculated in question 3.1.6. So it's literally here just about inputting your figures that were already calculated in the previous questions and calculating your coefficient of skewness. Now, when you calculate this answer, and here they asked you to interpret, when you calculate this answer, you do need to specify the type of skewness. So if you end up with a figure for question 3.1.8 that's equal to 0, you will say that there is no skewness. If you have an answer that's greater than 1, you will say that there is a positively skewed data set, or it is a positively skewed data set. And if your answer is less than 1, it is negatively skewed.
Hi, Akina, it's Kathy again.
Yes, sure. Kathy, sorry.
Can you hear me?
Yes, now I can.
Yeah. I think just for the students to give clarity that these formulae are on the formula sheet. Correct?
Yes, correct. They are all on the formula sheet. Some of them I think are not. I think the percentile calculation, there is no formula on the formula sheets. There's obviously nothing for the mode as well. But for the group data, which is the next question, pretty much all of it is. I think there's everything that's on the formula sheet.
Perfect. And all the formulas are not, but Jeshna, and just clarification on that. And they don't have to do a diagram with the skewness. It's just using the formula. Perfectly?
Yes,
perfect.
Correct. Yeah.
Ria asks,
if
you get any of these answers wrong, you're bound to get the rest wrong too. Ria, do you want to elaborate on that question, perhaps?
Good evening. Yes. So yeah, let's say you do get like your mean incorrect, the answer. And obviously you do have to use it in another question that comes after that. So if you've gotten that wrong, you're bound to get that answer incorrect as well. Is that correct?
Not entirely. There are part marks allocated where you are carrying through correctly. So if you went about calculating it in the correct way and you knew how to calculate it, or you use the correct formula, it's just that maybe there was an error with typing it into the calculator, for instance. As long as your figures are correct, you can possibly get a method mark for that. And then a lot of the time also where you're carrying through. So one question needs something from another question and so on, like you were explaining just now. There are also method marks for just carrying the figure through because you knew to use the figure in that formula. So it's not entirely lost. Not everything will be lost. Naturally, you will lose marks if it is incorrect, but it's not a situation where you're going to get a flat out zero. In a question where you did carry it through correctly or you knew the method involved, it was just the final answer that was incorrect or a final answer that was carried through, that kind of thing.
Okay, thank you
Ria,
so
does
much for
that
that
help you?
explanation.
Okay, great. Yeah,
Kath,
no
is
other
there anything that
question.
I'm the chat? No, nothing else I missed in the chat.
No, Akita, the only thing was that students, which we can clear up on this, have asked if they can join other sessions. And I said I didn't think it would be a problem because I'm doing a session tomorrow on Learning Unit 5, and I don't think there's a problem with students joining collaborations. Are you okay with that, or not so much?
I have no problem with that at all. It's just that we might have to check if it's fine in general. I'm
I've
not
checked with
sure if it's a general
Ali.
rule.
It seems okay. I mean, ideally students should
Okay,
keep
okay.
to their same groups, but I see Daryl's next session, sorry, is only on the 27th. And I
Yes, which
happen to
was
have one
supposed to be too
tomorrow
late.
on Learning Unit 5. So if you're comfortable with it, I'm happy for
Yes,
students to join.
yes, of course, definitely. No, as long as
Okay.
it's not allowed and I mean it is allowed and there are no issues with that, definitely. I do agree it might be too late for the 27th when the assignment's due on the 28th. So it might be cutting it too fine, and I'm sure students obviously would want to have most of their assignments done by then.
Well, we would like to believe so. We've got an intelligent bunch here. Okay, perfect. But I mean, I've cleared with Ali, and it's not our norm, exception rather than the rule.
Yes.
But yeah, we can do it. Okay, okay, perfect.
Yes, I do agree. I think all the help that you can get is appreciated and welcomed. So I think that's perfectly fine. So there's one last question for 3.2, and that was quite an easy one to construct a bar chart. And it is for 8 marks. They've given you the brand of coffee that a person prefers, and then the number of consumers that prefer each of those brands. So just a little hint when you're drawing up these bar charts, not one of, the main things that we do look for is firstly a title to your bar chart entirely that must be included. Then you must have labels for your, oh, sorry, I went a bit skew. So when you are drawing up your X and Y axes, there needs to be a label, a heading for the Y axis, and then the X axis as well. Please make sure to pay attention to that. Then when you are drawing up your bars, remember a bar chart has spaces between the bars, And also, when you draw up the bars, make sure to write down the value of that respective category. So, for instance, you have Nescafe here and it is 20. So, you'll write down the number 20 on the top of the bar. So, that's pretty much it when it comes to drawing up your bar chart. Just make sure that you have your titles, your label for your axes, your bars are separated, your headings are on your bars, or your numbers are on your bars, and that would be it for your bar chart. Any questions or anything you're confused about for the ungrouped data section?
Nope, everybody's happy.
Okay, perfect. So we can then move on to the group data question. And this is the last question of the assignment. So if you're choosing to do this question, then it will be, sorry, let me off the assignment. So if you're choosing to do this question, then it will be, sorry, let me just clear the screen there. So if you're choosing this, it's pretty much the same type of questions as the previous one, as question 3, which had your ungrouped data. The only difference is that here, naturally, you're working with information that is grouped, or they are categorized as intervals of data, and you're looking at calculating using specific formulas that are involved. So here, I think all of these formulas are in your formula sheet, which is also at the back of your assignment. And it's also in your textbook as well, at the back of your textbook. But I would suggest sticking to the one that is at the back of your assignment, because it is the most recent one. And it is the one that will be in your exam as well. So it has all of the formulas for learning unit 3, for your grouped data section specifically. For your ungrouped data, as I was saying just now, there are, I think, about 3 or 4 formulas that are not included, about, I think, between 2 and 4 that are not included. So let's have a look at this question. It says to you that the following table indicates sorry, just looking at the chat.
Hi,
Yes,
Keela,
I
sorry. Are you
Oh,
in agreement?
yes,
Sorry.
I do. I'm on the fence actually, because on one hand, I feel like it's a good way to get a really high mark in your assignment, and then obviously have a high CAS. And then on the other hand, I totally agree that it really does prepare you for the exam. So if you're going with the option of um, choosing group data here, then you obviously are more prepared for the exam. But also, on the other hand, it's also an option in the exam. So they still do have the option in the exam to choose between these sections.
Okay. Thanks for that clarification. But I think
So it's a
okay,
tough one.
it is a tough one.
Yeah, so students can, I mean, if they really are struggling um, in, with this group data section, which, as you said, is more of a difficult section, then they do have that added bonus of it also being a choice in the exam. So you still have the same choices that you had here with Learning Unit 3, where you will choose between your grouped and your ungrouped data. So if you really are struggling with it and totally hate group data by the time you're done with it, then I do suggest you sticking with the ungrouped data. But honestly, I have found over the past year specifically, even in our full-time space, that students love the grouped data section. For some reason, they feel confident enough, and I think they've got to the point where they're good with the calculations. So it might surprise us. People might just choose group data.
Yeah, Akila, I'm in complete agreement. I think it's actually far more interesting, exciting, and far more valuable for any form of market research that anybody's going to go into. But Carista asks, are the choices definitive in the exam, or must they still study both and expect the unexpected?
So in the exam, it still is a choice, but we will be speaking more to that in your NSS session ahead of your exam. So we will be indicating to you that this is a structure of your exam. These are the questions that you can expect. These are the choices you have for each of the different sections. So I will definitely be communicating it to you guys as well. And Kath will also communicate it to her groups, Dal with his group. But we will give more clarity. We will provide more clarity on that closer to the exam. Just for now, we will leave it as a huge question mark. But just as a general note from this year, it is choices in your exam as well.
Yeah, until we give further clarity, I think just to make sure you engage with both. Definitely.
Yes, agreed. And there is also an assignment brief, sorry, not an assignment, an assessment brief that will be made available. So you can also we obviously will discuss all of that closer to your exam.
Well, on a side note, just in its entirety, I mean, stats, are you not finding it fun and enjoying the entire program? So you want to engage with every learning unit anyhow.
Look, for you and I, Kath, definitely. But I'm not sure that everyone shares the sentiment with that always.
Okay, I'll leave it back to you. I know others have to get back. Sorry to keep interrupting. On group dates, need deep dive, Krista, yeah.
Yes, so it obviously is a bit different, and it is a lot more than the ungrouped data section is, but I honestly do prefer it myself. I feel like it is, like Kath pointed out, it's a challenge, it's interesting, it's different. So if you're willing to take on that challenge and you're excited enough about it, then please do, by all means. Okay, so let's get started with that question. So question 4 is based on your grouped data. And this says to you that the following table indicates the number of customers per week who bought a screen protector from a cell phone accessory store over a random sample of 60 weeks. So they've given you the information in the table, and they've said to you, so if you look at the columns, you have the number of customers in the first column, and they have categories, or rather intervals, that go from 0 to less than 10 customers, which technically means 0 up until 9. And then you have 10 up until less than 20, which means 10 till 19, including 10, including 19. 20 to less than 30, which is 20 to 29, including 20, including 29, and so on. So it goes up to 50. And then you have the number of days in the second column, which is 8, 9, 23, 11, and 9. So for instance, the first one, the number 8, is saying to you that on 8 days, there were between 0 and 9, or including 0 and 9 customers, up to 9 customers during that particular day. So here In total, you have 60. Sorry, just trying to highlight that. So you have 60 number of days in total. That's your sample size. They said to you to calculate the following and to use whatever applicable formulas and methods are necessary. And they wanted you to first calculate the mean and interpret your answer, then your median, interpret your answer, the third quartile, interpret your standard deviation, your coefficient of variation, and your coefficient of skewness. Okay, so sorry, before I start with that, can I ask for like a 1 minute break? I'm going to go into load shedding. So I just want to switch on my backup so that we don't get cut off as soon as load shedding starts. Just a 2 minute break. Kath, you're good with that?
Yep, I'm good with that. We're just clarifying and said days instead of weeks. It should say weeks on the paper.
Oh, yes, I do see that. Correct.
Yeah.
It's over a random sample of 60 weeks. Okay, perfect.
Everybody
Yes.
can get some coffee. That's a good idea.
Okay, so 5 minute time out. Yes, I do need to switch over as well, just so that we don't get cut off when load shedding kicks in.
Okay, perfect.
Thank you.
are we back? Okay, we'll just wait for Keela to join us.
Yes, I am back as well.
Yay!
I'm sure
We are
everyone
the
is
last
pretty
question,
much
so
over
not much
this.
longer.
Yeah. I'm sure
But you and I
everyone's
could do it
over
all
this by
night. We
now.
could just carry on.
Okay, I promise it's almost over. Okay, so back to the questions that they had.
Okay, we've lost
Remember
you,
that they
Keela.
wanted
We lost you for a bit.
Sorry, guys, can you still hear me?
We
I feel
lost
like
you
I
for a
cut
little
off
bit.
there a bit.
I think you just need to start again from where you were going to start from. We lost you for a little bit. Akila, we're not hearing you. Are you? Okay, we've lost Akila for a moment. Okay, she's reconnecting. Ladies and gents, this is the most exciting section. You back with us, Akila?
Hi, guys. Sorry.
Okay, yay, you back.
Yes, Murphy's Law. I had to get disconnected now. Okay, but I think it is all clear. So, again, back to question 4. They had asked you for the specific questions. So, your mean, median, your third quartile, your standard deviation, your coefficient of variation, and your coefficient of skewness. So, here, before even getting started with these calculations, my best advice would be to, just as a rough copy, because there are no marks allocated to this, for your own benefit, I would advise you redrawing this table just roughly in your whatever notebook you have, wherever you're working out your answers, and adding on 3 additional columns to this table. So the 3 additional columns are going to be X, which is your midpoint. Then it's going to be Fx, which is your frequency. That was the information provided to you here, which we said should be the number of weeks, not days. So that is your frequency that has been provided to you. And then Fx is each frequency multiplied by the respective midpoint, but I'll explain it in a second again. And then your last column would be Fx squared. Now, the reason we're calculating the values in this table is because it makes it much easier for you to calculate the values as you go along, because most of what you need is actually in this table now. If not, pretty much everything you need is in this table. So it's actually 4 columns, not 3. I just wanted you to add on this last additional column, which is the cumulative frequency. So here, let me just write that down. So here you've added on 4 additional columns. as I said, the point of the additional columns is that it's giving you everything that's necessary to calculate the values of each of these questions. It makes it easy because instead of calculating them and trying to find out where the figures are coming from as you go along, you already now have them in this table, and you're literally just referring back to the table, identifying which interval or what the total is, that kind of thing. And you don't have to actually do as much work as you would have needed to if you didn't have the table. So your cumulative frequency column is literal to the word cumulative. It's just adding on each successive frequency. So basically, the first one would be equivalent to the first frequency. Then 8 plus the next frequency, 9, would give you 17. 17 plus the 23 would give you 40. Sorry, it's not writing. Okay, there we go. 40 plus the 11 would give you 51, and 51 plus the 9 would give you 60. And then here in the next column, you have your frequencies that were provided to you already. They gave you the number of weeks, which is your frequency. And then you have the midpoint. So your midpoint is calculated by taking your first value of your interval, which for the first one is 0, plus your second value, so 0 plus 10, and dividing it by 2. So 0 plus 10 divided by 2 would give you a midpoint of 5. Then 10 plus 20 is 30 divided by 2, which would give you 15. And then 20 plus 30 divided by 2, which would give you 25, and it'll continue like that. So that's your midpoint. And then in the next column, you have fx. So it's each multiplied by its respective midpoint. So I'm just going to put that within brackets so that you don't get confused between the multiplication sign and the x, which is your midpoint. So it's literally saying each f value, so for instance, the first one is 8, that's your frequency, multiplied by its respective midpoint, which is 5. So literally in line with it. That's what we're saying here, the respective midpoint, and that would give you 40, for instance. And then you'll do the same for the rest of them. 9 times 15, 23 times 25, and you'll continue. And then your last column, which is fx squared, is squaring the x value. As you can see, the square is attached to the x. So x is being squared, and then it's the frequency multiplied by that x squared. So it's almost the same as this formula that I wrote out here, with the only difference being that the x value is squared. So for instance, the first one would be the frequency of 8 multiplied by x is 5, and it's 5 squared. So basically 8 times 25. And then the next one would be 9 times 15 squared, and then 23 times 25 squared. And you'll continue in that manner until you get all of your fx squared. Once you're done with the table, also include at the bottom your sum for each one. So here you would have the sum of x, sorry, no, we don't need that one actually. You only need, actually you don't need many of them. So I'm just going to erase what you don't need, and I'm going to leave what you do need. And I'm going to leave what you do need. So you need that column and that one. Okay, so you actually only need the last two here, which is the sum of fx. So basically summing up all of these fx values. And in the last column, you need the sum of fx squared. So having this table makes it extremely easy once you start to calculate the values and you need to identify what the sums are or which interval you're using and so on. So let's start with the calculation. So the first one, which is to calculate your mean, is calculated as the sum of fx over n. So now that you have the table drawn up, here's the sum of fx already calculated in the second last column, and here's your n value that they already gave to you in the table. So it's just the sum of fx over n, and that would give you your mean. So again, here you can stick to 2 decimal places unless they state otherwise. And then you would need to interpret as well. The interpretations can be done in the same way that they were. So for example, your mean is the average. So you could say the average number of customers per week, ... And that would be your interpretation. Then the next one was your median. So your median requires a little bit more work than the mean did. And this is then the first step, and I'm going to write the steps on the side here. So your first step is going to be to calculate your position. Your position here is calculated as n over 2. Now, this is different from your ungrouped data because with your ungrouped data, the position is n plus 1 over 2. Here, it's just n over 2. So it would be your value of n over 2. That would tell you your position. The second step is to identify which interval. So let's just say, and I'm just giving you a random example here. Let's just say that you calculated n over 2 and it gave you a value of maybe 26. So if you calculated 26, it's basically saying to you that the 26th value in your data set is your median. Now you're using that to determine your interval. And the easiest way to determine your interval is to look at, and this is why we also included the cumulative frequency column here. The easiest way to identify where the 26th value lies is you're going to look at your cumulative frequency column and look at where the value of 26 would fall. So for instance, if you look at these two, so here you went from having 17 values as your cumulative frequency to 40 values in the next interval. So this is saying to you, when you brought in the next interval, initially you only had 17 values, but when you brought in this next interval, 20 to 30, somewhere along the line, you found the 26th value. So this then tells you that your interval is 22 less than 30. So this then becomes the interval that you work with. And that then leads you also to the calculation for step 3, which is where you're now starting to put in figures into your median formula. So your median formula then says OME plus, and then it's n over 2 minus the sum of the frequencies in the groups before the group you've selected. And you can either put the C on the outside or the inside here. You'll get the same answer either way. And that's over your frequency of your median group. So you can also put the C on the top here. I'm not sure if you can see that. Let me actually write that below that line. So that would be OME plus n over 2 minus the sum of your frequencies in the prior groups over the frequency of the group itself. And as I said, you can have the C attached at the top, or you can just put the C on the outside of the entire bracket, but you'll end up with the same answer either way. Okay, so here, the OME is the first value of your interval. And please remember, this is just an example that I'm doing. It's not obviously not your actual answer, but I'm just using an interval to show you where the figures come from and what figures get inputted into the formula. So the OME is the first value, the lower limit of your interval. And then you're adding on n over 2, which was already calculated in your position in step 1. So you can actually put in the figures for n over 2, or you can just put in the value. So like here, you calculated, let's just say it was 26. You can also just write the 26, or you can actually put in the fraction of n, whatever n is, over 2. Then it's minus the sum of the frequencies, and as you can see, it has a less than sign. So this is saying to you it's the sum of the frequencies of all of the groups before the group that you selected. So you selected the group 20 to less than 30. You're going to look at all of the groups before it, and I just want to erase here so that you can see that clearly.
Hi, Akila's Kathy again.
So the group you, yes, sorry, Kathy,
Sorry
but
to
are we
disturb
hearing?
again.
I'm not sure if
I've been trying to share the formula sheet with the students because I think then they will possibly know exactly where the different columns are coming from. But I cannot because I'm not a moderator. I don't know if you, I mean, I know everybody's got their formula sheet, but it'll be important for you to possibly have it in front of you so you can see exactly what Akila is referring to with the different variables, etc. Just a suggestion. Sorry, Akila.
No stress. Do you want me to share it? Is it something in particular you wanted me to point out in the formula? Or you want to show them
I
the
think just the
formulas?
formula sheet, because one question came up that
Just
it's not
show
the
them
same
what
as
it
the
looks
one in
like.
the textbook, which I don't have the textbook right next to me at the moment, but definitely the one we use for the exam is the one in the formula sheet. Sorry.
I actually think it's on this assignment. So let me just try skipping the pages. Oh, sorry.
Sorry to
My
interject.
screen zoomed in so majorly for some reason. No stress. Let me see if I can change the pages here.
I think it's just for them to realize the adaptation
Yes,
of the
so
formula
it is at
sheet
the end
to,
of the.
yeah, it is.
Okay, it is at the end of this assignment that's up on the screen, but I'm not sure if it's pulling through on your end. I think because it's load shedding on my end, it's giving me a bit of a difficult time.
It's not pulling
Oh, okay,
through
there we go.
and
I think it's showing.
it's pulling through some things, but yeah, can see something. So I think it's just so they can see the reference. Thank you.
Okay, no problem. Okay, so here it is here, for instance, the mean that we were looking at just now. It's essentially, naturally, it has a lot more that's included in it, but it's essentially just, let me clear that. It's essentially exactly what it says here. And then the median that we're working with now is also the same thing, exactly the same thing. And then I pointed out to you that you can also just include C in your numerator rather than on the outside, but either way, it will give you the same answer. So just an idea of that. And then there are more formulas on the next page as well. So just now when we were working with your ungrouped data, we saw your standard deviation, for instance. So that would be here. So it's the same thing. Actually, this is your variance. So your standard deviation. So it's the same thing. Actually, this is your variance. So your standard deviation is the square root of that. So it's literally just the square root of that answer. And then just now, when we're going to be looking at the standard deviation of this group data, this is the variance, but the standard deviation is the square root. So it'll be the same formula, but just that it's the square root of that answer, because the standard deviation is the square root of the variance. So this is a copy of the formula sheet that is at the back of your assignment. It's not the full formula sheet because it is only including whatever was relevant for this assignment. You'll see that as well in your copies of the assignment. It's only about half the formula sheet because, again, it only includes the formulas relevant to the learning units in this assignment. So specific to learning units 3, 4, 5, there's actually no formulas from learning unit 5 that will be in the formula sheet, even for the exam. So learning unit 5 in its entirety, you will have to know that learning unit and its formula.
Keela, hi, we've lost you again. Gaston, just about learning unit 5. No, none of the formulae are on the formula sheets. It only goes when we go into probability distributions, which is learning unit 6. So learning unit 5, you're going to have to learn all the different formulae. But once you understand the concepts, it's pretty easy peasy. But we've lost Akila.
I am back. Sorry.
Oh, yay.
Sorry.
There you are back.
Sorry.
Okay. Handing back to you.
Thank you, Kath. Sorry, my apologies. The load shedding is just killing this whole session. Okay, there we go. So back to the, oh, gosh, all of my work's being destroyed. Okay, so as I was saying before I got cut off, not all of the formulas for, I'm not sure if you were discussing that as well, Kath. Not every single formula is included for every single learning unit, but the majority of it is included. But just learning unit 5 doesn't have anything that's in the formula sheet.
Yeah, that was one of the questions which I just answered. But no,
Okay,
your work is at least saved on the recording, and I think I've probably prolonged why the session's gone longer. So sorry, because I keep interjecting.
no worries. No, it's good.
Okay.
It's totally relevant. Everyone's gonna benefit from it. Okay, so back to that question. Just trying to get back some of the stuff I had written here. So with your median, then we were saying, I think I share the sentiment, Nate. I also am at that point, that low point right now. All right, so with your median, third step is then to calculate and put into the formula. We said it is OME plus your N over 2, we would have already calculated. It is to, and I was saying to you here, which interval was it that I was using? I think it was 20 to less than 30. Was that the correct one? Yes, so 20 to less than 30 is the one that I was using. And so if we're looking at the sum of the frequencies in the groups before this, then you are saying that these are the two groups prior to the group that you're working with. And all you're doing is you're summing up their frequencies. Remember, this is the question for the frequency. And this is then 8 plus 9, for example, which would be 17 here in your formula. And then the frequency of the median group is going to be, if this is the group that you selected as your median group, then the frequency of that group is 23. So that would be 23 in your denominator. And then the C on the outside, or if you're putting it into the numerator, is just the interval width. It's the difference between the values that make up your interval. So you could just work out the difference between 20 and 30. Or if you are looking at specifically what the values are in that interval, it's 20 up until less than 30, which is 29, including 20, including 29. So if you literally go back to the basics of the basics and use your fingers to calculate here, it would be 20, 21, 22, 23, 24, 25, 26, 27, 28, and 29. So C on the outside would be 10. But as I said, if you just want to go the easy route here, it's just looking at the difference between the 20 and the 30. Okay, so that was your median. And then, as I said, it's interpreted in the same way that you would interpret it, which we discussed just now under your ungrouped data. So interpret the same way. It's just obviously different values that are going into your calculations. Then you have your third quartile. And this is following the same steps that your median did. So your median is your median is carried out in the steps of first determine your position. Do that here as well. Once you have your position, determine your interval, which we also did with your median, and we'd do it here with your third quartile. And then calculate the quartile itself. And the formula as well is quite similar. So the formula for your Q3 is OQ3 plus, and then you have 3n over 4, again minus the sum of the frequencies in the groups before the group you selected, over the frequency of the group itself. And again, you can either put the C into the numerator or you can put it on the outside. So your position of your third quartile is calculated as 3n. You have your n value, so that would be pretty straightforward. And then your interval, so again, the same way we identified your interval is, let's suppose that this value was maybe, sorry, let me just fill in the figures I had here, and then we can refer back to this. So let's suppose you calculated your position, and again, just hypothetically, let's suppose you calculated it, and hypothetically, it gave you an answer of 46 as your position. So this 46th value in your data set is your third quartile. Again, just an idea to give you an idea of how to calculate it. So here, once you have the position, to identify which interval it falls into, look at your cumulative frequency column where you see 46 would fit in. So for instance, here you went from 40 to 51. So with the value of 40, 46 was naturally not included here. That's telling you so far there were 40 values. But when you look at the next one, 51, it basically says to you that when you added on this interval, 30 to 40, it basically says to you that when you added on this interval, 30 to 40, this is now where you found your 46th value. So your interval that you would then be working with is 30 to less than 40. And then again, you're literally using that now to plug in your values or to identify values from your table for the formula. So OQ3 is the, remember, first or lower limit, first value of that limit. So that would, for instance, be 30 plus 3n over 4 was already calculated here, so you can just put in the figure if you like, or you can plug in the values for the fraction. And then it's minus the sum of the frequencies in the groups before the group you've selected. So again here, if this is a group you selected, which is the 40 to 50, it's all of the groups before it. You're summing up those frequencies. So it's the 8 plus the 9 plus the 23. That would give you the figure of 40. So it would be minus 40 here. And then it's multiplied by the C, which is again the interval width. It's the difference between the values in your interval. That was the value of 10. Sorry, I'm just going to write this a little lower so we can see that clearly. So it was 30 plus 46 minus 40, and then you had 10 on the outside. And then it's a frequency of the group itself. So of the group 30 to 40, the frequency is 11. So it would be over 11. And like that, you'll calculate your Q3. And again, it's interpreted in the same way that it would have been interpreted under your ungrouped data. So it's just about saying 75% of your number of customers, sorry, 75% of the time, the number of customers is below this, or the upper 25%. You can say it in either direction. So this is your third quartile. And then your standard deviation is using the formula, as I said, that we saw at the back just now. So this is calculated as the root of, it's the sum of fx squared minus n multiplied by your mean squared over n minus 1. So the sum of fx squared comes from the table. It's this last value in the last column. And here, another reason why it's so beneficial to have drawn up this table. You literally don't have to do any work at this point because you would have already initially calculated it. So the sum of fx squared is the last value here minus n. They gave you n in the table. Here it is here. And then you have it multiplied by your mean, which is then squared. Your mean was calculated in question 1 here, so you don't have to actually go back and calculate this. So that's also done. And then you have in your denominator n minus 1. So again, n you have, and then that would give you your standard deviation. As you can see, that's for 7 marks, which is quite a lot, because naturally you would have had to have already calculated the sum of fx squared. There's quite a bit, I think about 2 to 3 marks that's allocated to having correctly calculated that. You don't need to show the working out of it, as I pointed out earlier. You don't need to show the table. It's for your own benefit. There are no marks allocated to the table, but it really will make a world of a difference having done it already at the very beginning, so that as you go along, you saw that we kept referring back to the table. Most of the things we needed are in this table, and the sums of it as well we used for certain calculations. So that's your standard deviation. The next question is your coefficient of variation. So your coefficient of variation, if you recall, we did earlier from the previous section, your ungrouped data, is calculated as your standard deviation over your mean. So here it's multiplied by 100 so that you can express that as a percentage. Your standard deviation would have already been calculated in the previous question. Your mean already calculated in question 1. So there's not much that's going into it. This is why it's for 3 marks. All of your answers were already taken from previous questions. And then remember to leave that as a percentage to 2 decimal places. And then the last one on this page is the coefficient of skewness also calculated in the exact same way as your ungroup data. It's 3 multiplied by the mean minus the median, and then that's over the standard deviation. So again, here, pretty much everything you needed was already calculated for you in some of the previous answers. You need the mean that was done in question 1, the median in question 2, and your standard deviation in question 3. So all 3 of the values for that formula were already calculated. And again, here, remember, when you get to your final answer, they asked you to interpret. If it's equal to 0, then there's no skewness in your data set. If it is an answer that's greater than 1, then you will say that your data set is positively skewed. If it is less than 1, then it will be that your data set is negatively skewed. And then the last question is looking at drawing up a grouped frequency distribution table. So they've said to you that the following data set includes the number of people per day who contacted a roadside assistance organization over a random sample of 20 days. They've given you the figures randomly. They said to construct a grouped frequency distribution table for this data set. And your table should include columns with the headings, descriptive headings, indicating the frequency count. So your frequencies, your percentage frequencies for each class, and the total. So your frequencies, your percentage frequencies for each class, and the total for each of the latter columns should be included. Please don't forget about that. And they said to you to use the classes 20 till less than 25, 25 to less than 30, and so on. So they actually gave you a starting point here in terms of your columns in terms of your number of customers that are, what was it based on? Number of people per day who contacted the roadside assistant. The number of people is, they gave you a starting point, 20 to less than 25. So that would be your heading. So they told you pretty much what to include as your headings here. So the number of people would be your first column, and they gave you the starting point of 20 to less than 25, then 25 till less than 30, and you'll continue like that. Remember, stick to the intervals that they've used. As you can see, they've used intervals of 5, so please continue in that manner. Remember, you stop at the interval where the highest number in your data set falls into an interval. So you'll look for the highest number in your data set and make sure that you have enough intervals so that that number will fall into one of the categories. Then you have in the next column, you will put in your, so I'm going to do this one first, your number of days. And this is going to be your frequency column. And in order to get to that, you'll need to do your tallies first. And then you have your percentage frequencies in the last column. That's literally what they asked you for here. So I'm just underlining what they asked you for. So for instance, and I'll just do the first one here to show you how you'll go about doing this. But there is also content in your slides in your textbook that shows you how to do this. So you're simply looking for, if the first interval is 20 to less than 25, you're looking for numbers that fall between these between these values, in this interval. So 20 to less than 25 technically means 20 to 24, including 20, including 24, because it's less than 25. So 20 to 24, including 20, including 24. And from the information, you have two values that fall into that category. So 22 and 23 would fall into that category. As a tally, you would write that as 1, 2. And then you'd write the number 2 under your number of days. And then in your percentage frequency column, once you're done with all of your intervals and all of your categories, whatever total you get here, for your percentage column, it'll be 2 over that total multiplied by 100. And that will give you your percentage frequency. So you'll do the same with the rest of them. For a tally, let's suppose in this tally column, you count the number of values that go into a particular interval, and let's say it's maybe 7. So as a tally, just in case you are not familiar with this, if you are writing out 7 as a tally, it will be 1, 2, 3, 4. A line through it to indicate 5, and then you'll start again with the 1, so it'll be 6, 7. So that's basically 5 and 2, which would give you the frequency of 7. Okay, so they asked you also to sum up. Please don't forget about that they want totals for each of the latter columns. So once you're done, make sure you calculate the total for those last 2 columns as well. All right, so that is it in terms of the assignment. Are there any questions in terms of question 4 that we just looked at?
Keela, can you hear me?
Yes.
Yeah, I'm just, I just want to, because it's relative frequency, which is a percentage frequency column, unless they request percentages, otherwise they must do it as decimals. Am I correct? I'm just preparing for possibly the on-campus exam.
Yes, correct. If they don't state that it must be a percentage frequency, they could also call it a relative frequency, and that would just be a decimal. So you wouldn't do the multiplied by 100 portion.
Thank you. Just, I just need that clarity in prep for the exam. Thank you.
Yes, definitely. Thank you, Kath. Any other questions from anyone? Or are you too over this to be interested in any questions?
I think they've all gone off to eat or sleep.
I
Just
don't
let
blame
their
them at all.
computers on. But from my side, thank you, Akita. That was great, and I hope the students really, I think they really benefited from this and good guidance for the assignment. And yes, I've got a session tomorrow with my students just to unpack Learn Unit 5, and but otherwise, I think you've been amazing. So thank you from my side.
Thank you, Kath. I see that some people in the chat are just, this is too much. But yes, hopefully it will bring a lot more clarity in terms of, even if not just for the assignment, I'm hoping for the exam as well. In preparation ahead of their exam, you can refer back to this and look at the type of questions. They're obviously the same type of questions that you can expect in your exam as well. So it's quite beneficial to listen back on at a later stage ahead of the exam. But obviously we'll have our own NSS session then as well. Yes, I do hope the bit on the calculator was useful. And I know that you did put in links on the chat for the calculator methods to follow, but I also actually do have a worksheet, which I will also send to you, Kath. You can possibly share with your group. So you have one. I'm not sure if you have one. I think you did mention that.
I do have one I couldn't upload, which is quite narrow, but when buying your calculator, there comes that wonderful little booklet which nobody ever reads, and believe it or not,
Yeah.
it has that info on it.
Nice.
But yeah, I have a worksheet, but I couldn't upload it. So if you can upload it as the moderator, that would be great. I think for the students. I know one of the students has got the Sharp financial calculator, which is slightly different. But otherwise, the Casio and the Sharp scientific are not too far
Yeah.
apart.
Yeah. Um, the problem with uploading it is that only the students, I can't, even if I upload it onto the session right now, it's only going to be the 5 students that are on the session that can download it, because after the session takes place, it's no longer um, downloadable, if I could say.
Then just share with me what you've got, and I'll share what I've got. And yeah, thank you
Yes,
so much,
definitely.
Akila. It was a very informative thing. I think the students are very, and they're all dropping off quite quickly. So it's going to be left with you and me
Yeah.
chatting.
Thank you, guys. Thank
Okay.
you, everyone. I'm so
Thank you
sorry
very
for stressing.
much. Okay.
Enjoy
Cheers.
your evening. Bye.